Okay, quick update on our bait worm mold project. So this is the mold, or this is the bait that I got from the guy that I work with, and I tried to 3D scan this. We got a little Creality Otter dealie with the turntable, and I 3D scanned this guy, and I ran into some issues. So let me talk about some of the issues I ran into. This 3D scanner, it is a pretty, it's got its own quirks. And so there's items that scan really well and items that don't scan really well. So let me talk about some of the challenges I ran into here. This guy, it's smooth and shiny. Smooth and shiny stuff don't show up in the 3D scanner very well at all. So what we got is this stuff, the A-Sub Blue. It is a spray. It's like tough actin tinactin. You shake it up, you spray it. It's like a powdery kind of, well, it ain't really powder. It's like spray, but it basically like, it's kind of foamy powdery and it evaporates. So you can come in here, spray our worm down, and then put it on the turntable and then spin it, shoot it with the camera, and the little particles of this stuff all over the worm like creates a texture that can be picked up by the camera. I tried that and I ran into a bunch of issues. So here's a couple of the issues I ran into. Number one, this thing, it sits flat on the ground, but it's not symmetrical. Like if you look right here, there's a little hump where the thing is not touching the surface. So what I ran into was when I scan this, it creates, oh, my focus is messed up. When I scan this, it puts a flat bottom on the bottom of this whole thing. And going into it, I was thinking, well, that'll be easy to fix because the whole thing is symmetrical. So if I scan it like this, I ought to be able to just like pick a plane like that's basically like halfway up. So like if this is touching the ground and this is touching the top of the worm, I should be able to pick a plane halfway up the worm and slice the worm along that mid plane all the way down, and then just mirror the top half to the bottom half, because the top has got all the texture it's supposed to have, and the bottom, the scanner is going to make the bottom flat, but if I mirror the top to the bottom, I could get this nice texture all the way around the whole thing. The problem is, because of how this sits and like this is not actually in line, like you know, it is connected to the center of this tail, but its weight makes it hang down on the table, so it's no longer aligned with the center of this worm. Basically, I wasn't able to do it like that because like stripping off the top half of this worm would not get the top half of the tail because the tail's too low. So I did some stuff like post-processing stuff in Creality Scanner to try to like remedy that. I was not successful. I tried some like smoothing, some hole filling, that kind of thing. So then I basically got stuck with having to model this worm, which is not ideal because this is like very irregular geometry. It's what they might call like organic geometry. It's not based on like straight lines or polygons or like now the secret spoiler is actually it's just like really irregular geometry. But so I took about measuring it with my little American caliper right there, that boy. And what I ended up with first, I printed this yesterday on the way home. This is my first prototype. Obviously it's a little wonky. It's like the straight section was too long, and the tail doesn't flare. Like, see, the tail here flares and then this one doesn't. So this is what honestly, I spent like several hours yesterday working on this, kind of trying to tweak the tail geometry, and it was a little bit of a challenge, but it came out okay enough for you know, some iterative work. I can take this guy and modify it to get closer to what I really wanted. So then that's what I did today. I made this guy. So you can see too, like if I just overlay them, if I get right over the top, overlay this one, you can see that the issues that it's got. But if I overlay this one, hey, so I almost got a 1-to-1 good solid model on this thing. Now it looks weird from the side because like the plastic one is rigid and it's not gonna sink. So, you know, that one actually lays down flat. This one is like lifted, you know, it hovers because it's rigid. But now that I got this worked out, the model, I'm gonna be able to use this model to make a relief inside a bait mold. So what I'm kind of thinking, I just do a little quick sketch on the table right here. Also, if you got a workshop or something like that and you don't got a table that you can write on, man, get you some kind of board or something you can put up there and write on, because like it's really useful to like put a part on the table and then just like mark off, you know, dimensions off of the part. What I basically got to do is do something like this. Let me think about my size constraints. That may be too big, but I'm thinking to orient one of these in here and, you know, another one like that maybe, and then another one here maybe. If I can get 3, that would be like amazing. But I'm gonna get a couple of these cavities in a rectangular prism, and then I think I'm gonna have a hole, a tiny pinhole that goes from the tip of this tail, and it's like a vent hole that goes straight up out the top of the box. So you look at the top of the box, you'll have a tiny pinhole on this side that goes down to that tail. You'll have a tiny pinhole here that goes down to that tail, and you'd have a tiny pinhole like here that goes down to the third tail. And that's so when you inject the plastic in the end of the mold, the air hole is going to let the air escape so you don't get vapor lock. So all your plastisol actually goes into the mold and completely fills the mold because it's following the path of least resistance, and that air gap or that air vent hole from the tip of the tail is kind of like, it's kind of creating like capillary action where the plastic's going to like jump in there pretty enthusiastically. For the sprue, maybe have the hole somewhere on the side. So the sprue could like connect to all the heads of the worms. So when you shoot the plastic, you're actually getting all 3 worms filled simultaneously. So I don't know, like I said, I got some tweaking still to do on it. But this is a good model. This one's called Worm 2, is Worm 1, Worm 2. So what I'm gonna see about tomorrow is working with this model for Worm 2 and creating a negative of it, a cavity. And I also need to see what the max build volume is in my metal printer. This is what we got. It's the Desktop Metals Studio System. It's not huge, but it's not tiny either. I'll just show you my hand for reference, like put my hand spread out on the plate. So maybe about the size of American football is probably about like what our max volume possible is. So I'm pretty sure I want to say that I can probably get at least 3 worms in there. And yeah, we'll go from there. Another thing I was thinking, I might try to get some TPU or some other more like elastic kind of filament. And I don't really have any experience printing in TPU. Everything I've done has been like PLA and PETG. I want to see about getting some TPU and see like, can you just print these worms and what's their consistently like, or their consistency, excuse me. And I realize like that may be cost prohibitive because probably this is maybe more expensive. You printed it out of TPU. It's probably a lot more expensive than what you would want to pay for a rubber worm like this. But just for fun and to kind of get some reps in working with other like slightly more exotic filaments maybe. So that's what I got going on. Thanks everybody. Stay tuned.